Okay? So, again, side tangent about simplifying and solving. If we are simplifying something like the square root of 4, we get 2, right? If I'm solving an equation where I have x squared equals 4, then I get 2 answers of plus or minus 2, right? Last class we talked about, well, if we did the, what example did I do up there? Sine inverse of the square root of 3 over 2. If we simplified that, it has to be either in quadrants 1 or quadrant 4, and we're asking ourselves what angle is going to give us a y value of square root of 3 over 2 in quadrants 1 or quadrants 4. What answer would you give me? The y value that's going to give me a positive square root of 3 over 2 is going to be angle pi over 3. Yeah? Okay, if you don't have your gold sheet out, I would grab it out because we'll use it a lot today. But if I were to evaluate the equation sine of x is equal to the square root of 3 over 2, now there's not just one y value that gives me the square root of 3 over 2 on my unit circle, right? This would be an answer of still pi over 3, but also what other angle? 2 pi over 3. So do you see how you're going to have more than one answer when you're solving a trig equation versus if you're simplifying a trig inverse equation? See the difference there? Yeah? Okay. Because this inverse thing is due to my range values that we had from our regular sine function. Great. Okay. So here's just a few little notes if you're struggling to figure out what to do when you are solving a trig function, because just like the rest of this stuff, there's not just like a cookie cutter way of do this, this, and this, and you're done. You gotta have to kind of use some processing skills and figure out if something doesn't work, try something else, okay? So if I look at number 1 here, we're gonna figure out if it's a linear or a quadratic, which means like we might have to factor with trig functions. It's gonna be okay, I promise. If there is only one trig function that is in the equation, then just isolate that variable and solve it like normal. If you have more than one trig function, make it so that it is equal to 0 because you might be able to factor something out. And then if you have two things that are next to each other, like if I had, x plus 5 and x plus 2, and that equals 0, how would I solve that? We wouldn't FOIL it. Yes, right? This is just back from algebra, right? That's called the zero product property. So you can set each factor equal to 0. If you ever see something factored, I do not want to see you guys FOIL it back out when you're solving it because it's already done, right? If it's in quadratic form, but you can't factor it, cry a little, but then use the quadratic formula. Don't cry, please, okay? But you can use the quadratic formula, or you can use your graphing calculator to solve it for you. And I'll show you how to do that here at the end. Okay, if that doesn't work, we'll do one example today of using a trig identity in order to change something so that it is in terms of just one trig function, so that way we can evaluate it. But you will have to check for extraneous solutions, okay? For all of the equations that we're going to solve, you're always going to be looking at the interval from 0 to 2 pi. Okay, so you might have one answer, you might have 2 answers, you might have 4 answers, you might have 3 answers, but it is only from the interval 0 to 2 pi. So we're not going to include 2 pi as an answer for these things, okay? All right, let's go ahead and jump on in here. I've got one trig function here, right? I've got sine of x. So let's isolate this. If you see a trig function and you freak out, just let that sine of x be a. If I solve this equation, 2a plus 1 equals 0, you guys know how to solve that, right? Subtract 1, divide by 2, yes? So we're going to do the same thing for this equation, but with sine of x. So I'm going to subtract 1, so I got 2 sine of x is equal to negative 1. And then divide by 2, so sine of x is equal to negative 1/2. And then now you're going to go to your gold sheet. You're going to ask yourself, what angle is going to give me a y value of negative 1/2? Y value of negative 1/2. I've got 2 answers there. 11 pi over 6 and 7 pi over 6. Okay, Both of those give you a y value of -1/2. It is an equation, so I want both of them. It's not an inverse, so I don't want just one of the answers. Okay? So that would be your final answer. Okay, again, I've got only one trig function here, right? Tangent of x. Let's isolate that. So I'm going to subtract 1. 2 tangent of x equals, what is -1 minus 1? -2. It's not 0. And now what am I going to do? Divide by 2. So now, another good thing that you might want to think about adding to your note card is all of the tangent functions, the tangent values. The tangent values are not marked on here, right? So it might be helpful to add those things on there. I'll put that over there as well. But where is my tangent? What angle am I going to have a tangent value of -1? 3 pi over 4 and 5 pi over 4. Wait, 5 pi over 4 would give me positive, right? Yeah, 7 pi over 4. There you go. Okay. Again, y over x, that's going to give you a -1 at those two angles. Okay. I've got 2 secant of x plus 1 is equal to secant of x plus 3. Technically, I've got two trig functions there, right? But they're the same. So what do you think we could do? Subtract it, right? If I rewrote this with a instead of secant, and this was my equation, you would subtract that a over, right? So let's do that. Subtract 1 secant of x from 2 secant of x. That gives me 1 secant of x plus 1 is equal to 3. Subtract 1, and I'm left with secant of x is equal to 2. Now, I don't know about you, but secant of x, thinking of that in my brain of how to find that on the unit circle is a little tricky. So could I rewrite secant in terms of a different trig function? Yeah, which one? Cosine. This is the same as, not 1 over cosine, but cosine of x is equal to 1 over 2. It is the reciprocal. So on your gold sheet, on your unit circle, where is my x value? What angle is my x value going to be 1/2? X value, yes. Sorry, I was looking at the wrong one. Yes, pi over 3 and 5 pi over 3. If you were also looking at y, I was too. It's okay. Okay? Questions on that one? Okay, how many of you want to FOIL this? No, good, great. Because I've already got the two set of parentheses, and they're both going to equal 0. So I'm going to set this thing equal to 0, and I'm going to set this thing equal to 0. And there should be a little x there. Got a little typo. But now I can set up two equations and solve. So I've got cosecant of x plus 2 is equal to 0. And cosecant of x minus the square root of 2 is equal to 0. Okay, so starting on the left here, we're going to subtract that 2. And then I don't know cosecant very well on my unit circle, so I'm going to rewrite cosecant as sine. So this is going to be sine of x is equal to -1/2. Okay, so look on your gold sheet. Where am I going to have a y value of -1/2? 11 pi over 6 and 7 pi over 6. You guys are killing it. Okay, the next one's going to be very similar, except it's going to be equal to the square root of 2. So then I'm going to flip that. So sine of x is actually equal to 1 over the square root of 2. Now, that's the same thing as what? 1 over square root of 2. Root 2 over 2, right? So if I look at my gold sheet, look at my unit circle, where am I going to have an angle that's going to give me a positive square root of 2 over 2? Pi over 4 and 3 pi over 4. Okay, this is the first one where I have two trig functions that are different, okay? Now, if I let like x be sine and y be cotangent, for example, like this, okay? If I'm solving this equation, I do not want to ever see anyone just cross out x, okay? The only thing I want to see you do is subtract the x over and then do what? Factor it out. Because if you just get rid of it, you just got rid of an answer, right? Technically, when I factor out an x here, I'm going to be left with y minus 1, and then I get two answers, right? Because I set this equal to 0, and then I set this equal to 0. So you cannot ever just cross out one of the trig functions, okay? Same thing if you wanted to like rewrite cotangent as cosine over sine. If I wrote sine of x times cosine of x over sine of x, I cannot just cross those things out, okay? We have to move this over, get it equal to 0, and then factor. Okay, so I'm going to move this sine of x from the right side over to the left. And then now this is equal to 0. I can take the sine of x out from both of these. Factor it out. When I factor out the sine of x, you'll be left with cotangent of x minus 1. Okay, so now I can set up two equations. The first equation is going to be sine of x is equal to 0. The second equation is cotangent of x minus 1 is equal to 0. So looking at your gold sheet, where is the sine value going to equal 0? What angle? I heard 2 pi and pi. We are right. 2 pi, remember if you think back to the very beginning, that interval is from 0 to 2 pi, but we're not including 2 pi. So instead of writing 2 pi, what should I write? 0. So our two answers would be 0 and pi. Okay. And then the right one, cotangent of x is equal to 1, which is the same thing as tangent of x is equal to what? 1, right? The reciprocal of 1 is still 1. So where on your unit circle is my tangent value going to be positive 1? Pi over 4 and 5 pi over 4. So I've got 4 answers for this equation. Now this one looks a little bit messier, but let's think about writing it in terms of just a. Let's let a be my cosine squared. This would be then a squared plus 2a plus 1 is equal to 0, right? Where a is technically cosine. So if I solve this quadratic, if I can't factor it, I'd have to do the quadratic formula. This one we can factor. So if I go ahead, do my cross product sum, this is your a times c value on top, your b value on bottom, if you forgot. So that means I am multiplying together to give me 1, adding to give me 2. So what two numbers is that? 1 and 1. You might have learned how to factor a little bit differently. That's fine. However you factor is fine with me as long as you are factoring correctly. Okay, so then when I'm going to replace, or when I'm going to factor this thing here, I'm going to have the cosine of x times the cosine of x, because that's going to give me cosine squared, right? Or I think that's your a and your a, right? And then what am I going to put right here? Plus 1 and plus 1. And then I can just go ahead and set one of those terms equal to 0 because you're going to get the same thing regardless. So cosine of x is equal to 0, which means we're looking at where is cosine of x equal to a negative 1? Yeah, at pi. And that's the only place, right? That's the only x value on my unit circle that's equal to negative 1. So that right there would be your final answer. Okay, number 7, I've got 2 parentheses here. So I should do what? Set them both equal to 0. Okay, so this is going to equal 0, cotangent of x minus the square root of 3. And then 2 sine of x plus the square root of 3 is equal to 0. If I solve the one on the left for the cotangent, I get the square root of 3. And if your brain doesn't think in terms of cotangent, we can switch this into tangent. And that means the reciprocal of the square root of 3 is 1 over the square root of 3. So we're looking at our gold sheet. Where are we going to get a tangent value of 1 over the square root of 3? Pi over 6 and 7 pi over 6. Okay, I'm gonna let you guys go ahead and finish out the blue side if you haven't done so yet already, and then we'll check to make sure we got the same answers. We all agree with those? Yeah? Wonderful. All right, last example, we'll take a quick break, and then we'll finish up with the calculator. Okay. Now, cosecant squared of x is equal to 2 cotangent of x. If I, tried to move it over, could I factor anything else out? No, not really. So we got to think a little bit outside the box, aka look at your gold sheet. What does cosecant squared equal? One plus cotangent. So I could rewrite this with number 11's identity and say that this is 1 plus cotangent squared of x. Because now I have everything in terms of cotangent, right? And if I have a quadratic, we should probably do what? Set it equal to 0, right? So move this 2 cotangent over, and I'm going to rewrite this like cotangent squared minus 2 cotangent x plus 1. Because now we can do what with this? Factor it. If you're, super scared about the cotangents, factor this first. A squared minus 2a plus 1 equals 0. So we're thinking what multiplies together to give us 1 and adds together to give us -2. What two values is that going to have to be? -1 and -1, right? So I'm going to have cotangent of x minus 1 times cotangent of x minus 1. So I've just got to set one of those factors equal to 0, which means we're looking at cotangent of x is 1, or we're looking at where is tangent of x 1, which we've already answered before once, but where is that going to be? Where is our tangent value equal to 1? Pi over 4 and 5 pi over 4. So this one only has 2 answers. Okay, so this one technically could be done, but you would have to use the quadratic formula, okay? Which you are more than welcome to do, but I'm going to show you how to use the calculator, because you would have to use the calculator to do the quadratic formula anyways. So there's an easier way. Instead of doing the quadratic formula, I can set this left-hand side of my equation equal to the y1, and then I can set the right-hand side of my equation equal to the y2, because all we're trying to figure out is where are they crossing each other, right? But we do need to make sure we are on the interval from 0 to 2 pi, okay? So I will show you how we're going to type this in, and then what I want our window to look like, bless you. In our window tab, I want you guys to make sure for your x minimum, you are at 0, and your x maximum, that you are at 2 pi. You can literally type in 2 pi. Okay, for your y minimum, it doesn't really matter. Let's just do -10. And your y maximum, we can make sure that's at 10. Other thing to make sure of is that you are in radian mode on your calculator. And then as long as all of that is typed in correct, you're in radian mode, and you type both of these things in, we should be okay. So the way that you're going to type this into the calculator is like this. I'm going to go ahead and insert a picture of what that should look like. Okay, so my y1 is 3 times the sine of x, squared, minus sine of x. Make sure that this entire sine of x quantity is being squared and that you don't put the little 2 in that parenthesis. Okay, it's got to be on the outside of that. So if your function looks like that on your y1 and y2, and your window is all set up, okay, with those values, you should be able to see the graph, okay? We'll also put on here what your graph should look like. Okay, so your graph should look something like that second picture there. So take a minute and plug all this stuff in. If you guys have questions and things, let me know and I'll come around and look at your stuff. So now on your calculator, you're gonna go ahead and do second trace, and you will choose option 5, which is the intersect option. Okay, if you hit enter, then it'll take you to your graph again, and you're gonna have a little plus sign on here somewhere on your graph, and you wanna move that plus sign to where they are crossing. So like if I move it to this point right there, if you hit enter 3 times, it should give you the intersection values for that point. And then you're gonna have to do it all over again, second trace, and go to the second intersection, enter 3 times, and then go to the third intersection and hit enter 3 times. Okay, so I want you guys to test this out, but you should get the following 3 answers. You should get 1.571, 3.871, and 5.554. Okay, those are the 3 answers that you should get from your graph after you've done the second intersect option. Okay, let me know if you don't get those and I will come help you. So those are your 3 answers. Again, you can technically solve this doing quadratic formula, but if you're gonna use a calculator, I would graph it instead of doing the quadratic formula, because then there's more mistakes you're gonna make, yeah? So last example here, let's set it up the same exact way. We're gonna let this be my y1, and we're gonna let the other side be my y2. Okay, you still want your window to be from 0 to 2 pi and then negative 10 to 10, so you're not changing that. You still also want to be in radian mode. But then once you've graphed both of those, I want you to double check the answers that you get are 1.196 and 5.087.